Hey there, first graders! Today we are working in science on Unit 6, Daylight Patterns, Lesson 8, Daylight Patterns Portfolio. Even though this portfolio assignment is complete and turned in during Lesson 8, we will actually begin working in Lesson 4 today. That means this portfolio is 5 lessons long. My name is Mrs. C, and I will take you through every step to complete this portfolio. You can complete it all in one day, if that's what you'd like to do, or you can spread it out across 3, 4, even 5 days. That way you don't feel overwhelmed with so much work. Before we begin, let's go ahead and pull up your lesson so we can see what we need to do first. Objective and key words. In this portfolio, you will think like an engineer about how to design a device to measure daylight hours. That's our objective, or what we want to do. Our key words are daylight, the light from the sun we see during the day, device, an object made to do a special job, and shadow, an area that shows where light has been blocked. The engineering design process. In this portfolio, you will think like an engineer. Engineers follow steps to solve problems. Look at the chart to see the steps. Ask, brainstorm, design, create, test, improve. These are all steps of the engineering design process and all steps we are going to take during your portfolio. You will follow these steps to make a device to measure patterns of daylight. A pattern is something that happens again and again. Daylight has patterns. Two are the change between night and day and how the amount of daylight changes during the year. Shadows during daylight also follow patterns. Watch the video to learn more. So you can watch this video and you can talk about it with your learning coach. You can use shadows to measure daylight patterns. In this portfolio, you will make a device to help you measure daylight. You will, number 1, ask questions about shadows and daylight. Number 2, brainstorm ways to show daylight patterns. Number 3, design your device. Number 4, create your device. Number 5, test your device. And number 6, improve your device. You will use your science journal to record your work. Your journal should include all of those parts we just went over. You will complete your journal and you will send it to your teacher. Talk to your learning coach and decide how you will save and turn in your work. Here's a rubric that you can look at now, and we'll also look at it together at the end of this video to make sure we've included every part that we need to. Here's a new objective. In this portfolio, you will ask questions about daylight patterns. That's how we're going to begin in our science journal together. Here are some new keywords: device, an object made to do a special job, and sundial, a device that shows the time by the position of a shadow cast. In this portfolio, you will solve a problem. How can an engineer make a device to measure daylight patterns? Asking questions is the first step. What is the problem? In this portfolio, you will ask questions about a device that can measure daylight. Your device will use the pattern of daylight. What time is it? Look at a clock. How did people tell time before there were clocks? They used sundials. Watch the video to learn more about sundials. After you watch, you can think about these questions. How does a sundial work? What is the first step to solve a problem? How did people tell time before we had clocks? And what are the parts of a sundial? Now it's your turn. How can you use daylight patterns to measure time? Ask questions to find out. Here's our science journal. Work with your learning coach and write questions that you have about using daylight and sundials to measure time. You can use these words to start your questions. How? What? Where? Why? When? or who? Write your questions in your science journal. You don't have to write a question for every single one of these words. Just choose one or two that you can begin a question with. Here's my example in my science journal. I have two questions. Number one, how can I measure daylight with shadows? And number two, what time of day will make the biggest shadow? Those are the questions I have. Your questions don't have to be the same at all. Whatever you want to know, you can ask. Make sure you record it in your science journal. All right, here we have another objective. In this portfolio, you will brainstorm a device that uses daylight patterns to measure time. Here are our key words from this lesson. Daylight, the light from the sun we see during the day. Device, an object made to do a special job. Engineering design process, a series of steps engineers follow to solve a problem. And sundial, a device that shows the time by the position of a shadow cast. In this portfolio, you will brainstorm a way to measure daylight hours. Brainstorming is an important step in the engineering design process. So we already asked questions. Now we're brainstorming what are some of the possible solutions. You will think of possible devices. They will do these things. Use daylight, use patterns, measure time, and show differences in the number of daylight hours. Brainstorming about sundials. People used daylight patterns to tell time long ago. They could tell time using the sun. They made sundials. So click right here. You can view the gallery and it will show you pictures of different types of sundials. Think about these questions. What is brainstorming? Think about the devices people use to measure daylight patterns. How are they all the same? How did people use daylight patterns to tell time? Talk about these questions with your parent, your sibling, your caretaker, your learning coach, and see what answers you can think of. Now it's your turn to think like an engineer. How can you make a device that uses daylight patterns to measure time? Here's our science journal again. Now we're going to brainstorm. Try starting with these statements. I can make a blank to measure time with daylight. I can use a blank to make my device. Brainstorm your ideas in your science journal. So if you'd like to, you can use those sentences to help you, or you can think of your own ideas. I wrote, my device needs to be tall to block the sunlight. I can stand my device in my yard. I need to be able to measure the shadows. So I want a place that's nice and sunny outside, and I want to make sure that I have something that will block that sunlight so I can measure the shadow. This is the end of lesson 4. You might want to stop here when you're done brainstorming and continue on tomorrow. I'm going to go ahead and move on to lesson 5. And you can pick up and watch again another time, or you can keep going right along with me. Here's our new objective. In this portfolio, you will design a device that uses daylight patterns to measure time. So that is what we want to do for this whole portfolio. Our keywords are device, an object made to do a special job, media, a way of communicating or expressing information, and sundial, a device that shows time by the position of a shadow cast. Design a device. In this portfolio, you will design a device. Design is an important step. Engineers do these steps next. Look at the ideas from the brainstorm step, think about them, and pick the best one. Here we are on the third step, design. What is the best design? Making media of your design. You can use media to share information like websites, podcasts, books, movies. We like to share what we learn. We can write a book about it. We can make art. We can make a website. You will design a sundial. It will use daylight patterns to measure time. Your media will have these things: a list of all you need to make the sundial, a list of all the steps to make the sundial, and a picture of your sundial. You can use a computer or a tablet to make your media. You can also use paper and crayons. So sometimes we might want to make our project very fancy. We might want to use something like a presentation. So you could make that on a computer. And of course, we're also going to continue using it for our science journal. That's like making a book, sort of. Making media is an example of the 21st century skill known as creating media. Media can be printed or it can be digital. It is important to know how to create media. Then you can understand different ways to share information. What happens during the design step? What is part of a good design plan? And why is it important to make media for your design? Go ahead and think about those questions and talk about them with your learning coach. Now it's your turn. Look at the ideas you have and choose the best one. Make a plan to make your sundial. So this is the design step. Work with your learning coach and maybe try starting with these sentences. I will need ... I will follow these steps. 1, 2, 3. I will measure the patterns of daylight by, and you can write or draw your design in your science journal. So here's my example. In my design section, the first thing I did was list the materials that I would need. I need a tall stick, Play-Doh or clay, chalk, and a flat sidewalk. Then I need the steps or how I'm going to do this project. Number 1, I will gather my materials. Number 2, I will use the clay to hold my stick up straight. Number 3, I will write the hours with chalk and draw a circle around. And number 4, I will check the stick's shadow on the sidewalk at different times. So that is my plan or the steps I will follow for my device. Make sure you design your device in your science journal. Remember, you can use pictures and words if you would like to. This is the end of lesson 4. Now, lesson 5. We're done 4 and 5. Now we're going to move on to lesson 6. If you want to take a break and come back, that is absolutely okay. So this is the third lesson. Remember, there are 5 altogether for this portfolio. Objective. In this portfolio, you will create a device that uses daylight patterns to measure time. Here are the keywords from this lesson. Create means to make. Device is an object made to do a special job. And a sundial is a device that shows the time by the position of a shadow cast. Create your device. Now it is time to create. This is an important step. Look, 1, 2, 3, 4. It's the 4th step of the engineering design process. What steps will you follow? The ones that we just wrote down in our design. Engineers create or build their devices. They use the plans they made in the design step. In this step, you will use the plans you made in the design step. You will follow the steps to build your sundial. Answer these questions. What happens in the create step? Why do you need to do the design step before the create step? Now it's your turn. Look at the plan you made and use the plan to create your sundial. You're going to write down or draw a picture in your science journal. You can try starting with these sentences. I made a sundial by, and then did you have to change anything? Did it not work out? You could write, I did make changes to my plan or I did not. Here's my create section in my science journal. I wrote, I made a sundial by using a stick and chalk. So for my sundial, I made it outside. I didn't draw a picture of it, but I did take some pictures that I could share with my teacher. Here's a picture of my sundial on the sidewalk. You can see this is my Play-Doh with my stick in the middle. I've got all the numbers of a clock going around, and you can see the shadow cast is showing that it was 3 o'clock in the afternoon. Here's a picture even closer. You can see that shadow points right to the number 3. So you can draw in your science journal if you'd like to, or you can take a picture of your project and share that with your teacher as well. All right, let's go back to your lesson. That's already the end of lesson 6. So just the create section was in this lesson. I'm going to go ahead and move forward to lesson 7. It took a long time to think that time. All right, here's our new objective. In this portfolio, you will test your design of a device that uses daylight patterns to measure time. The key words are daylight, the light from the sun we see during the day, device, an object made to do a special job, and sundial, a device that shows the time by the position of a shadow cast, just like the one you just created. Test your device. In this portfolio, you will test your sundial. This is an important step. Engineers do these things. Test their device to tell if it works, repeat the test many times to make sure it was good, and write down what they find out in their tests. Here we are, moving right around this engineering process. Think about this when you test. What worked and what didn't work? Sometimes not everything works out, and that is okay. We can improve those things. Think like an engineer. You will test your sundial. Place your sundial outside. See how it measures daylight. Repeat your test a few times. Test at different times of the day and on different days. Try to test your sundial in different types of weather. How does the weather affect the results? Think about these questions. What happens in the test step? Why is it important to test your device several times? Now it's your turn. You have made your sundial and now it is time to test it. Does it work? You can record your information in your science journal. Try starting with some of these sentences. I will test my sundial by. I can test my sundial on blank days. My sundial. Write or draw about your test in your science journal. So here is my test section of my science journal. Yours does not need to look just like this at all. You're going to record your information from your test. I wrote, I will test my sundial in the morning, afternoon, and evening. Those are the different times I plan on testing mine. And I can test my sundial on sunny and rainy days. What do you think? Is it going to work really well on those sunny days? What about on those rainy days? Those are the things that we can test and we can find out the answers to. Objective. In this portfolio, you will compare your design of a device that uses daylight patterns to measure time. Here are the key words. Device, an object made to do a special job, and sundial, a device that shows the time by the position of the shadow cast. Hopefully, you've seen exactly how that works now. In this portfolio, you will compare your sundial with one made by another person. Engineers test their design in these ways. They repeat the test many times, they write down what they find out, and they compare their device to others. This step helps them make sure their test was good. So we're still in the testing step. We're just doing a different part of it. We are comparing. After you test your sundial, you will compare your sundial to another one. How are they the same? How are they different? You can compare your device to others. Did one idea work better than another one? Watch this video to learn more about comparing sundials. So in this video, that's what they're going to do. They're going to compare some sundials. Here's more about the sundials in the video. Sundial 1, sundial 2. In sundial 1, there was a stick in the ground that makes a shadow. But in sundial 2, there was a straw and a plate that makes a shadow. In sundial 1, the numbers are painted on rocks, and in sundial 2, the numbers are drawn on the plate. In sundial 1, it tells the time well. In sundial 2, it does not tell the time well. Compare the two sundials in the video and think about this question. How are they the same? Then think about this question. How are they different? You can also answer these questions with your learning coach. Why do we compare the results of tests? And why do engineers compare their devices to other devices that are like them? Now it's your turn. You can compare your sundial to others. Use the ones in the video or ones you found online. So you can use the ones from the video. You can use Mrs. C's if you would like to. You can also do a search online. So right here, I just typed in making a sundial for kids, and I found many examples. So you can look at any of these examples and you can compare the sundial you made to one of these. It's up to you which sundial you decide to compare. When you record your comparisons in your science journal, try starting with some of these sentences. My sundial is the same as the other sundial because, or my sundial is different from the other sundial because. Write about or draw the two sundials and show how they are the same. Then show how they are different. Compare how well they work. What works well and why? What does not work well and why? Which is the better sundial? So you are going to write some of those comparisons in your science journal. Here are my comparisons. My sundial is bigger than a paper plate sundial. Both sundials have numbers and use shadows. Both sundials worked as well. So you just want to record just a few simple sentences like that in your compare section of your science journal. This is the end of lesson 7. Our next lesson is lesson 8. This is when we turn in our completed portfolio to our teacher for a grade. Objective. In this portfolio, you will improve your device that uses daylight patterns to measure time. Our keywords: device, an object made to do a special job; improve, to make something better; sundial, a device that shows the time by the position of a shadow cast; and technology, a tool that helps solve a problem. Improve your device. Now it is time to make your device better. The improve step is an important part. Engineers look for these things: the results of their tests, problems with their devices, and ways to make their devices better. So think about, what changes will you make to improve your design? Look at your test results. Look at any problems. How can you improve your sundial to fix these problems? Make a plan for how to improve your sundial. Technology is a tool that solves problems. Sundials are technology for telling time, but they have problems. The amount of daylight changes with the seasons. That means the length of an hour changes each season too, so changes were needed. Sundials can only be used on sunny days. They do not work well when it is cloudy, so other types of technology to tell the time were needed. Hourglasses and clocks are also technology to tell time. 21st century skill. Thinking about how to improve technology is an example of the 21st century skill known as using technology. Technology is any tool that solves a problem. There can be many types of technology to solve the same problem. We need to look at all technology to see which works best to help us. Answer these questions. What happens in the improve step? What is technology? And what are some ways that sundials need to be improved? Now it's your turn. Look at your sundial. Look at your tests. Did your sundial work like you thought? How can you improve it? So you're going to record how you improved or your ideas to improve your sundial in your science notebook. You can start with I saw ... or I changed ... So here are my examples. They're not exactly the same as this, and they're not exactly the same as yours may be, and that's okay. Here's my improve section. I saw that some of my numbers were too close or too far apart. I used a yardstick to measure the same distance between numbers. Remember, those numbers need to be an accurate space apart or they won't tell the time correctly when the sun is moving in the sky. So that was my improvement that I recorded in my science journal. Reflect. We're all done. In this portfolio, you thought about daylight patterns, you made a sundial, and you used the engineering design process to help you. Now that this process is done, we're going to reflect, which means we're going to think about how it went. You followed all the steps. You asked questions about daylight patterns and sundials. You brainstormed ways to make sundials. You designed a sundial and made a plan to build it. You created a sundial following your plan. You tested your sundial and compared your results. And you improved your sundial based on your test results. Think about your portfolio project. Look at what you wrote in your science journal. Think and talk about your portfolio project with your learning coach. Use these sentence starters for help. You can use any of these. I learned that. My project was. The most difficult part. I was thinking like an engineer when I. You can use any of those to write your answers in your science journal. You could also write if you have any new questions about daylight patterns and sundials. Add those to your science journal too if you'd like to. Here is my reflect section. I wrote 2 sentences. I learned that you can tell time without a clock, and I was thinking like an engineer when I measured and improved my sundial. This is my reflection. Your reflection might be very different, and that's perfectly okay. It's what you think about your portfolio. All right, this is page 7. Here's page 8. This is the last page of your portfolio project. Get ready to turn in your portfolio. Make sure you have each part and work with your learning coach. So you should have the ask questions section, the brainstorming section, design section, create section, test section, compare section, improve section, and reflect section. Remember, each of these doesn't need to be its own page. If it is, that's fine. You can also put them together on a page if that works for you as well. Once you've collected all of these and made sure that they are all together, you're going to go to the next page and you're going to drop your assignment into the Dropbox for your teacher. Let's look at that rubric just to make sure that we've got everything we need in each of these sections. The first one, ask questions, says I can ask questions about a problem or a challenge people want to change. We definitely did that. We asked questions about telling time using sunlight and shadows. Brainstorming, I can imagine different solutions to a problem. Yeah, that's where you came up with your ideas for how we might be able to measure time. Design, I can come up with a detailed plan for the idea that I selected for my brainstorm. We definitely had our materials and our steps. That is a detailed plan. Create, I can follow the plan for the design. So yeah, if you followed all of those steps and you created your sundial, then you definitely did that. If you had to change anything, that's perfectly okay as well. Test. I can make a new tool or improve an old tool to solve a simple problem. So we've definitely had sundials before, but you made one yourself and then you tested it to see if you could make it better, if there was anything you needed to change. That is where the improve section comes in. You can compare different tools and decide which one will do a better job. You can also make changes or improvements based on what you learn to your tool. So that's your improve section. If you get all of those, I am sure you will get a really high score, hopefully a 30 out of 30 points. My name is Mrs. C. I was really happy to help you with your science portfolio today. I hope you get an amazing grade, and I will see you next time. Goodbye.